The GTO engine is assembled, primed, and ready to be installed, and I'll show you all the steps it took me to get here on this episode of Josh's Car Corner. Okay, I'm back to Reassembly, and the first thing I've got to do today is put my new lifters in before I put the cylinder heads back on. So I got rid of the LS7 lifters that I had in there because chances are the oil had metal in them. I wasn't going to be able to reuse them again. And number two, if you'll remember, the whole reason I'm here in the first place rebuilding this engine is because one of those lifters spun in the plastic lifter tray, and I don't want that to happen again. So I stepped up to what I probably should have done 7 years ago and went to a set of link bar lifters. Now, these ones are from Lunati, but what some people don't know is that the company that actually makes these lifters is Morel. Morel is like top notch when it comes to lifter technology for the LS motors and for small block Chevys. So what happens is instead of having the plastic tray in there, this bar ties the two lifters together so the wheel will always run true on the camshaft, and that problem will never happen to me again. So I've already put all the ones in the back side of the motor in, and I've got two of these in. I've got one bathing in oil right now. So Lunati wants you to put 10W30 on these things to set them in the motor. So that's what I've got here is just some Royal Purple 1030 that I had left over. So I'm just letting them sit in there for a couple of minutes just so the oil can penetrate all the passages and get them all full of oil before I throw them in there, and then I'll just drop them in there. So I'm going to get these out. I'm just going to shake all the excess oil off them quick. Just slide them one at a time in, and if they're well lubricated, which they should be, they'll fall right into place. So let me pull my phone out quick and I'll show you what it looks like in here. Okay, so you can see here I've got these rows of lifters installed. Now the link bar always goes up because if it went down it would run into the cylinder heads or into the bottom of the block. So you can see in there, if you look off to the sides, like looking between the V right here, you might be able to see on the camera, you can actually see one of the wheels of the opposing side lifter riding on the camshaft in there. So here's the bores empty, so there's your lobes that these are going to ride on. But then back there up in that hole, you can see the lifter's already installed. So it's a really compact package. It's really cool how they get this all put in here so nice and efficiently. So I'll get these in and we'll get to putting these cylinder heads on. Okay, all of the lifters are now installed. Now I need to clean these surfaces up on the block again. I did drop a little bit of oil on them when I was putting the lifters in. So the best way to do this is just to use some brake cleaner. Take a shop towel like this and get it very damp, but then you want to apply just light pressure. Light pressure because all of these water jacket passages have got jagged edges and they will shred shop towels, especially when they're wet. So just light pressure, let the brake cleaner do its job of emulsifying that oil and getting it off of the surface. If your towel does start to shred, get a fresh one. Don't take any chances. These are all the water jackets for cooling, and you don't want little shreds of shop towel running around in your cooling system. Okay, now it is time to install the new head gaskets. These are just GM factory head gaskets. These will work fine for me because these actually have a 4 20/20 inch bore, or 4.02 inches. So even though this is bored out to 4.01, these will still have enough opening to seal properly. So you'll see on the head gaskets that they are marked. They say front and also 6.06 liter, not that relevant, but these only go on one way. So this being the front of the motor, on this side, the writing is going to be upright so I can see it pointing toward the front of the motor. But on the other side, you have to turn it upside down so the front still is to the front. You just can't see the writing. You have to put these on right. They will fit both ways, but if you put them on backwards, you can be covering up water jacket passages that need to be open. So you have to make sure that you have these oriented the correct way. Oh, other thing to make sure, these dowels have got to stay in the block. They position the head and the head gasket to make sure they are perfectly centered. If they don't go on smooth, so that they do kind of jiggle in there a little bit, they're not a press fit. You can kind of jiggle them around and rotate them. I had to do that on this back one here just a little bit off camera. to make this head gasket sit on there properly. But now it's time to get the heads, and we'll start bolting them down. All right, here's that one. There we go. That side's on. That side's on. There we go. The thing about these cylinder heads is they are not unique to each side of the engine. You can interchange them, swap them around. I just remember which side these go on because here's my coolant temp sensor, which I broke during disassembly. That always goes on the front driver's corner. So I know this is the driver's side head, that's the passenger side head. I'm just gonna put them back on that way because, well, that's how they came off. So now it's time to put in the new bolts. And this time, instead of going with another set of factory torque to yield bolts, I decided to get some ARP bolts for two reasons. One, because they're not torque to yield, are reusable. You can use them over and over and over. And number two, well, they're just better. And if I ever decide to build another engine someday or take these heads off, it's just going to make the whole process a lot easier with these. I'm going to start putting these in. I'm going to lube them up as I go. They say to lube the threads and the top of the head, so that would be just this part, and then just this surface right here that the washer will contact. I'll lube those up, get them all in there, and we will start the torquing procedure. Okay, all the bolts have now been lubed, all the bolts have been driven down and are sitting at about 0 lash right now, and it's time to start torquing them. Now, because these are ARP bolts, the factory instructions get thrown out the window because those are for torque to yield bolts. ARP has their own set of instructions for this. They want these done in 3 stages. The big ones go first. First stage you go 25 foot-pounds, second stage you go 50 foot-pounds, third stage you go 80 foot-pounds. And then for the top 5, the little guys, you do those last and you only do those to 25 foot-pounds. Now you can follow the same order as the factory service manual, and if you don't know what that is, I'll put a link up in the top right corner here, one of those little clicking things, so you can go back to episode 26 and it'll take you right to where I put the instructions from the service manual on the screen, so you can see the order there. And if you're using torque to yield bolts, it will show you the stages for torquing those as well. Sometimes when you're tightening a bolt, it can feel like it breaks loose and starts turning easily again. That can happen, especially if your threads in your block have not been retapped and re-dyed. You can hit a little rough patch and get past it, and then it starts turning easily again. It's not anything breaking or stripping out, it's not anything bad, just keep going. And then after that last pass, you want to go around again and double check them all. The thing I definitely prefer about these over the factory torque to yield bolts is that you don't have to do that stupid 110 degrees or 90 degree turn, whatever it is. Whatever they tell you, it's 52 pounds plus 90 degrees. I forget what it is, but that is annoying as hell, because show me anybody who's got the tool in their garage to accurately measure that they've turned a wrench 90 degrees. Okay, those are all done. Now it's time to go back and do the little ones. Okay, well, while I'm waiting for my new push rods to arrive, I can start putting some accessories back on. So first thing I'm going to do here is put on the water pump. This is pretty straightforward. It's just 3 bolts on each side. The gaskets are exactly the same side to side. And torquing procedure is pretty simple. It's 2 passes. First pass, you do 11 foot-pounds. The second pass, you do 22 foot-pounds. And there's no need to use any kind of silicone or Teflon tape or anything like that. The gasket has got rubber seals in it. You just gotta put it on. Okay, next thing I'm putting back on is the alternator and the brackets for it. Putting this on first is easier than trying to put it on after you put on the engine mounts or other things around it. So just trying to do them in that kind of order. Now, there's 3 big bolts up front here, and then there's 2 little bolts on another bracket on the back. Every single one of these bolts gets 37 foot-pounds. You know what? I'm actually remembering something from the last time I put this together. These 2 back bolts are only 13 millimeter, and they're only that long. And yet, I've checked this again with the book. The book says 37 foot-pounds. But when I try to put 37 on them, they just want to keep turning, which makes me think they're getting stripped out internally. I think that's too much for bolts that small. Realistically, I think these bolts right here should only get 18 foot-pounds. Okay, now it's time to put these engine mounts on. Now, in case you forget which side is which, the left-hand side one is actually stamped on the bottom LH, so you know it's left-hand side. And these only get 3 bolts attaching to the block, and those all do get 37 foot-pounds. Okay, the next thing I'm going to put on before I put on this engine mount is this AC compressor bracket. These things have always kind of driven me nuts because there are so many bolts. There's 4 bolts holding the compressor on, then there's 4 bolts holding the bracket on, but you can't even get to one of the bolts until you've taken the compressor off. It's just a lot of hardware to get through, and I get it, the compressor's heavy, it needs a lot of support, but it's annoying to say the least. But 4 bolts here, they're all 15 mil, and they all get 37 foot-pounds. Now I can put this other engine mount on. The thing that's kind of annoying about these is there's always one bolt that's hidden underneath that's really hard to access, and on the other side I could barely get my torque wrench in there to torque it down. This one, I don't think so. That one's just going to kind of be by feel. I'm having to resort to a wrench that I never use, just because it's awkward and it works backwards of the way you would want, but it is the only thing that's going to fit in here. Well, that's 37, or close enough. Other thing to pay attention to on this engine mount, there is a little bolt sitting here on the front edge. This is a grounding point for the whole electrical system, so make sure that bolt is still there after you put this engine mount on. Okay, 2 more things I got to put on the front of the motor here. One is this bracket that holds the power steering reservoir right next to the power steering pump. And then the other one is the spacer for the power steering pump. Now what's funny is I've been putting all kinds of things on the front of this motor, and all the bolts so far have been 13 millimeters and 15 millimeters. But once you get to something that you're only going to find in Australia, 16 millimeters. Why? I have no idea. But these are 37 foot-pounds, and then the bolts that hold the bracket to the head are 21 foot-pounds, and then the bolts that hold the power steering pump to the bracket are 21 foot-pounds. Okay, I am back in the garage, and the engine is back on the motor feet. I had to take it off the engine stand, which I'm currently sitting on, get through all those oxymorons, because I wasn't able to spin the motor with the flywheel attached on the engine stand, and I really don't feel like taking the flywheel back off, so I just put it back on the motor feet so I can spin it for the next part. Because what I just got done doing is going through and measuring all the measurements for the push rods, so I can figure out how long a push rod length I need. I'm not gonna lie, this is the most frustrating thing I have done in this entire process. The problem is they're hydraulic lifters. So the way they're supposed to work is there's supposed to be oil pressure behind the little cup in the lifter mechanism, and that is supposed to, 1, cushion the push rod so the valve train's a lot quieter, but 2, it's supposed to be pumped up to give you the full amount of lift. But when you need to measure preload, you don't want any oil behind the cup. You want it to be empty. You want to rely just on the spring to create the resistance so you can get your preload measurement. Now, these Lunati link bar lifters that I've got, for an aluminum block with aluminum heads, they want a preload of 45 to 50 thousandths. So you're looking at a window of 5 thousandths of an inch that they want to see you operating within. If you want to take this task on yourself, you need to get yourself one of these. This is a Comp Cam's push rod length checker. This particular model is the 7702. This is the one you want because you can adjust the length of it from 6.8 inches all the way up to 7.8 inches. Now in most cases on an LS motor, your push rod is going to be somewhere between 7.4 inches and lower, maybe down to, maybe if it's extreme, you're going to be at about 7.1 inches or something like that. My old push rods were a 7385. And those were perfect for the LS7 lifters with the build I had. So I set this thing at 7300 so I would be at a known zeroed out number. Now for every time you rotate this out once, you go up 50 thousandths. So I rotated it out 10 times to go up half an inch, which has got me to 7.3. So first thing you do is you stick it into the engine and get it in the lifter. So there we go. I can feel I can feel the spring there. Then you got to take your rocker arm and screw it back down. Now with LS rockers, there is no adjustment for the preload at the bolt itself. This is not a solid roller system where your preload adjustment is made at the rocker stud. It doesn't work that way. The preload adjustment's all done with the spring in the lifter. So this bolt, regardless of what lifters, what push rods, whatever you're using, will be torqued down to 22 foot-pounds every time. The only exception would be is if you switch to a solid roller cam and you were using solid rockers. Then you would make the adjustment here. But because this is all hydraulic, this just gets torqued down to 22. So you torque it down to 22, like that. Now what you have to do is spin the motor over a couple of times. And you can watch that thing work. So here in a second I'll be able to see it go down. Yep, there it goes, starting to go down. So it's just got to go down and up. And I'll go through the whole cycle again. And this time, when it starts going down, I'm going to let it get all the way down. Then I'm going to leave it sit there for a couple minutes. What that's going to do is help to bleed down the lifter. If there is any oil in there, right now the cup is going to be all the way bottomed out in the lifter itself. It would be forcing all that oil behind it back out of the lifter. It needs to be out because any oil that's trapped in there behind the cup will create resistance, and can overpower the spring. It will throw off your measurement. You need to be relying just on the resistance of the spring in the lifter to get this measurement. So I'll just cut it here, and after about 2 minutes or so, we'll rotate it back up, and then I'll show you how I measure it with this dial gauge. Okay, it's been a couple minutes now, so I'm gonna rotate the engine again, and I'm gonna rotate this until all the pressure is back off the spring. And you'll feel the point where it stops. There'll be this little point where you'll feel the pressure come off and just go a little bit past that. Now I need to this is my rig set up for my dial gauge right now, because I had to find something steel to magnetize this to. So slides over here, and then get this up and on here. Okay, just like that. And then let me show you with my phone how you set this up. So when you do this, your dial gauge has to be aligned on 2 different planes. So the little bar on it needs to be parallel to the push rod. So they have to be, it basically has to be a straight line between the two. The other one is you need to make sure that it's straight up and down on the rocker. As you can see right now, it's a little crooked. I need to pull it over and straighten it some, like that. So there, it's straight that way, and it's straight that way. Now, the number you're starting from here doesn't really matter. You can turn this thing to 0 if you want, or you can just remember where you started. I'll just try to get it around 80 here. The problem is it's really finicky, and every time you nudge it, my setup is not perfect. It always wants to move a little bit, so I try to get it to like a 5 or a 0 number just to get close to a relatively common starting point. There we go, 75, that's good enough. So now, what you do is I've got this and a Allen wrench like this, and you just need to break it loose and start cranking it back. And then you'll see this number start to go up. Here we go. So there we go. So she's loose. We're already up to 5 thousandths. So there we go. 10 thousandths, 20 thousandths, 30 thousandths, 40, 50, 60, 70, 80 thousandths, 85, 90, 95. Oh, and that's where she stopped right there. So that's about 99 thousandths. So that is how much preload I have with a 7.3 inch push rod. So now what I need to do is take that math, and I'll just go back to this math I did earlier, where I wrote down 99. I just write it on there, and then I know I started at 7.3, so I will just subtract what I need to get to 50 thousandths preload, and it's looking like, based on the averages, I'm going to end up with a 7250 push rod for this particular application. Now every engine is going to be different based on the lifter you use, the rocker you use, if you decked the block, if you decked the heads, that all factors into it. The thickness of the head gasket factors into it, especially with some of these lifters. Like these link bar lifters, again, they want 45 to 50 thousandths preload, a 5 thousandths of an inch window, which is like, we can't even measure that. But if you get too much one way or the other on that, then the lifters aren't going to operate properly, especially if you go way too far to the heavy side. You could end up over pumping the lifters and opening the valves farther than you want to. That can cause problems where the valves start slapping the pistons. Or on the other end, if you don't have enough preload, the lifters can't get pumped up enough, and then it will create slop. The push rods could start bouncing, and the valves may not be opening all the way the cam is designed to open them. Now you know a kind of homebrew way to do it, but again, if you don't feel confident doing this step, have a professional measure it for you. It does make a difference. Okay, one more thing I'm going to put on the engine right now, and that is my new replacement clutch. Now, the clutch I had in the car before was an LS7 clutch, and I went right back to the same thing. That clutch was so reliable. It was nice, smooth engagement. It drove beautifully on the street, and at the drag strip, I could do 5,000 RPM launches with it, and the only thing that happened afterwards is it smelled for a little while. So the way I see it, why fix what ain't broken? I just went back to another one. Now, the one thing I did want to show off here is my new clutch alignment tool. This isn't actually a billet steel piece. I got this from TIC. In the past, I've used the plastic ones, but the plastic ones have got slop in them, and you may not necessarily get the clutch just completely centered on the flywheel when you go to install it. These have a much tighter tolerance. They slide in there, and they're very, very tight, so you should get the thing absolutely dead centered. It just makes installation of the transmission a lot easier using this. And since I imagine I'm going to be doing a few more clutches in my lifetime on LS engines, this is just a nice tool to have in my toolbox. So I'm going to start just by putting that in there. Now, the first thing I have to do is get my brake cleaner out and paper towel and thoroughly clean this surface off. It still has that protective coating on it when it was shipped, and I need to get that off before I put the clutch on it, because that will interfere with the bedding process and cause all sorts of problems. So that's got to get cleaned off first. Okay, so now we slide that in, and there you go. That should be as centered gets. Now, I can put the pressure plate on, but I also have to do the same thing, clean this surface off with brake cleaner first. What you use to line this up is, there's pins on the flywheel. You can see 3 pins that are all 120 degrees apart. So it's not these holes right here, not these 6 holes. It should be a hole right next to a bolt on each and every one. So I'll just see if this is the right alignment. All right, there it is. So just gonna use a couple bolts here to hold it in. These also need red Loctite, just to ensure that they don't back off. I'm just putting a one in right now just to hold it, because it could pop back off. These fingers are already engaging on the pressure plate, so I don't want it to fall off while I'm getting the other bolts prepped. Okay, so for these bolts, the service manual says it wants 52 foot-pounds in a single stage. So you don't have to work your way up to it, you can go straight to it. I probably will work my way up to it just because I like to do things that way. But for the sequence you do it in, they don't want you to go 180 degrees across. They want 2 triangles. So what they want is 1, 2, 3, and then 1, 2, 3. 2 different triangles. So just remember that, and you will be fine. Okay, now that that's done, pull that out. All right, and that should be perfectly centered in there and ready to receive the transmission. One more thing I'm going to put on back here before I'm done, and that is this, the bell housing. So you may not know, but you can separate this from the transmission, and in fact it makes getting the transmission in and out a lot easier, because these 2 bolts right here, when the engine is installed in the car, are a gigantic pain in the ass to get to. So it's just easier to put this on now and then slide the transmission into this later. It doesn't affect anything. In fact, once this is on, it makes installing the transmission a lot easier, because you just have to line it up with the holes right here, which are a lot easier to access. And because you're putting the slave cylinder on the transmission itself, it doesn't affect any of that either. So you just slide this on first, and it just makes life easier in the future. What's funny is the service manual actually gets down to the granular detail of giving you a pattern for torquing these bolts down. They all get 37 foot-pounds, and the order goes 1, 2, 3 at the top, 4 down here in the bottom left. Then it goes 5 up here, 6 higher up, 7 here in the corner, and then 8. No, 8 is down there. Yeah, 8's down there. So yeah, there actually is a torquing procedure for this, but single stage, 37 foot-pounds. I'm just seeing a little Loctite leaking out here. I want to clean that up. All right, so I'll get this on. And the other thing is, this will enable me to then put the inspection covers on now as opposed to later, just so that's one less thing I have to do while the engine is in the car. Okay, there's one more thing I need to reattach to the front of the engine here, and that is the harmonic balancer. Now, here is my factory harmonic balancer, and I could have just put this back on. I replaced it when I did the rebuild 6 years ago with a fresh one for 2 reasons. One, this is actually, you can't tell, but it's a 2-piece unit. It's got an inner shell and an outer shell, which are connected by this rubber ring in the middle. Now, the reason it's called a harmonic balancer, or sometimes it's called a dampener, is it actually is supposed to dampen the vibration pulses created every time a piston has a combustion stroke and forces the crankshaft around. These are fine when you have a factory engine making 400 horsepower or somewhere around there, but the more power you add, the more violent those impulses get from combustion, and the more this thing has to absorb. And because it's rubber, over time, they do deteriorate and wear out. You might be able to see on mine, the rubber is actually starting to come apart on the outside edge here. And these things are actually tuned to operate and absorb vibrations within a certain resonance, because there's certain RPM ranges where those vibrations can cause damage to the motor if they are not absorbed. So I was gonna upgrade it, and there's a couple of different alternatives out there. ATI makes a lot. I know they're very popular, and they also make underdrive versions too if you want to have a smaller pulley, and they are tunable. You can add weight stacks to them, and you can change the resonance they operate on. I chose, because this is a street motor, to go with this one. This is made by a company called Fluid Damper out of New York State. And the way this one works is it also is a 2-piece system. You can kind of see there's an inner shell here, and then this is the outer shell with the pulleys on it held together with these 3 bolts. But what makes this one different is there is no rubber ring. This has got a fluid silicone compound in it between the 2 shells that absorbs the shock. And because this is silicone, its resonance range is almost infinite. It not only absorbs resonance at high RPM where you want it to, but it also absorbs it down on the lower RPM ranges too. So especially if you've got an engine that makes a lot of torque at low RPM, where those impulses are also quite strong, this is going to work a lot better for you than a factory one or even an ATI, because ATIs are tunable. You can tune them to work good on the street at low RPM, but then they might not be as effective at high RPM. So because this works everywhere and it's made in the USA, I wanted to get this one instead. Gail Banks is one of the people that I heard talk about it. If you don't know who Gail Banks is, he runs banks power. Does a lot of stuff with diesels, not so much with gas, but he's got some fascinating web shows that he does, and he has this one where he unpackages products and shows them off. And one of the things he showed on his show was this. And these are very, very popular in the diesel world because such huge amount of torque from those impulses of the piston firing with diesel. You need something like this to absorb that shock. There are no timing marks on this. Right now I've got the motor back at TDC on cylinder number 1 for the combustion stroke. But what I thought I'd do is I would install this with the fluid damper right side up. So at least if I ever need to and look at it, I can know that I'm on TDC of number 1 roughly just by looking at this. So I'm gonna get this installed. Went to the local all our parts store and got a balancer install kit. So this is M16 by 2.0, which is this guy right here. Thread it into this tool like so, and then you install it, and then you drive it on with this washer and collar. So I'm gonna do that, and then I've got another ARP bolt to put on here to keep it all down nice and tight, and we'll get this installed. Okay, I am on the Reassembly home stretch. Just a couple more things to bolt on here and I'll be ready to prime the engine. So first thing to do is put in my new Harmonic balancer bolt. This is an ARP bolt. It's a special bolt. They use a 12.27 millimeter socket for this puppy, and the factory one's a 24 6-point, so bigger head on it. And it comes with assembly lube and everything just like before. This thing needs a whopping amount of torque, 235 foot-pounds. So most half-inch torque wrenches will go up to 250, so if you have a half-inch torque wrench, it should accommodate you. But that's how much you need to tighten this puppy up. There you go. So it's time to put in the push rods, keep spinning the motor, and get this thing set up and tighten these down. But once again, I went with ARP hardware. Now ARP, instead of using bolts like this, they use studs. So the way this works is you screw these studs down into the head. They have like a little 3.5 mil Allen hole on the top there. I've got a 3, but that's okay. They only want these down hand tight, and then they don't want you to use any of their ARP lubrication on them. There's not enough torque here to justify it. And then when you torque these down, when you're ready to torque down your nuts, you torque them down to 25 foot-pounds. The factory wants 22 foot-pounds on the bolts, but they want 25 foot-pounds on these nuts. Okay, so I'm going through putting these push rods in, and I've already done the first 4, so let me show you how I'm doing this. So, once again, using my assembly lube, just to coat everything, so as I'm spinning the motor over when it comes time to prime it, there is some lubrication there. So you have to do this in order of the firing order. So the order of the cylinders goes 1, 8, 7, 2, 6, 5, 4, 3. So what I'm doing, because the cam's a little more aggressive than the last one, I'm going just a little past 90 degrees. So if you look, this isn't quite straight up and down. It's a little past it. Just I want to make sure that both of those lobes are completely on their closed cycle. So I've put the push rods in. Now I'll take my assembly lube again and I'll coat the top of them as well. And I will coat the top of the valves because they also will need some lubrication during the priming process. These are 10 mil 12-point nuts, so you'll need that socket, and then again torque them down to 25 foot-pounds. I also kind of like to help the rockers line up straight. You see you can wiggle them back and forth a little bit before they're torqued down. I just kind of try to hold them in the straight line position just to help them seat a little better. There we go. All right, on to cylinder number 5. The reason I went with these ARP rocker studs is because, as we know, studs are stronger than bolts. It's better for the heads themselves because then you're not trying to screw a component into an aluminum head while there's already torque on it. This is all in an effort to keep the valve train under as best control as possible because I'm obviously running stiffer springs and now I'm also going to be running increased lift. There is the possibility that the factory bolts could get a harmonic in them and they could start vibrating around and these rockers could start dancing around a little bit. ARP being a stiffer, stronger metal should reduce the likelihood of that happening. One last thing I wanted to mention is that I again went with Manton push rods on this deal for a couple of reasons. One, they will make them to custom lengths down to 5/1000ths of an inch. So when I did the math on how long a push rod I would need, I figured out that I would need a 7/250 push rod. So I gave those numbers to Manton, and then they asked me what kind of motor it was, what valve train I was using, and also what push rod checker tool I was using. And they took all that information, did the math, and figured out that what I really need for this build is a 7/265 length push rod. So that's what they sent me. So it'll be perfect amount of preload for these Lunati lifters. Second reason is they are the thickest walled and biggest diameter push rods you can get inside a Gen 3 LS head without drilling them out. Most of the aftermarket push rods on the market have a 5/16 diameter. These have 11/32 diameter. A lot of those push rods have a 50/1000ths wall. Some of them have a 100/1000ths wall. These have a 1/20,000ths wall. So as thick as they come and as big a diameter as they come, the least likelihood of deflection and anything and bending under load. So it is about the best deal you can get. And when I got my push rods from them 6 years ago, they were $215. When I ordered them this time, they were $215. So their prices have remained consistent, and I like that. Great company, great to work with, and if you want to run beehive springs and do a street motor build that has reliability built into them, I would definitely recommend the Manton push rods. Okay, I've spun the motor over a couple times just to make sure that nothing is hitting, and it isn't. Now there's one last part to put on, and that is the starter. Okay, now comes the exciting part. The starter is back installed, and off camera I dumped 6 quarts of conventional 5W30 oil into the engine. When you initially have to break in a new rotating assembly, you want to use conventional oil. It just helps the rings to seat a lot faster and the bearings to seat better. And then once you've broken the engine in after a few hundred miles, you can switch to the synthetic of your choice. So I've got my battery hooked up with a couple of short cables that I bought at the parts store to the block and to the starter. And then I rigged up the solenoid to this momentary push button switch. So what I can do is I can push the button, that'll activate the starter, turn the whole motor over. This is how you have to prime one of these LS engines, because again, the oil pump is driven off of the crankshaft. The crankshaft has to be rotating in order to pressurize everything. So I have to do that, and what I'll do is I'll look in here, and on this side I put all the oil in. So on this side, once I see oil start collecting on the tops of the rockers and in the valley here, I'll know that I've got oil all the way to the top of the engine, and it'll be ready to fire, and it's primed. So once it's in the car, no lifter tick to worry about. It'll be primed, ready to go. So I'm going to get to that right now. So here we go. You want to go for about 15 seconds and then give the starter a minute to cool off. It wasn't designed to run continuously like that, and even though there's almost no load on it at all, you don't want to risk overheating it. So just give it a minute to cool down, and then you can go again for about 10 to 15 seconds. Well, it looks like there's still air. That's an air bubble. So there's still air in some of these push rods. Okay. So maybe I'm not there yet. Looks like a little more priming will be in order. Booyah! See the oil, I stopped it and the oil started bubbling up through the push rod. So she is now primed. That is it. Now all I have to do is put the valve covers back on, and this engine is ready to install back in the car. And that's going to happen on the next episode of the show. And hopefully by the end of that episode, she'll be ready to fire back up after, God, 8 months now. Almost coming up on 8 months. So thanks for watching the project to this point. And thank you again for watching Josh's Car Corner. See you next time.